So these last 4 problems are just practicing the adding, the subtracting, the multiplying, and the dividing one more time before we try it in class. So this one is subtracting, and remember with adding and subtracting, so 2 and 5, you really just combine the like terms. You combine the real parts and you combine the imaginary parts. Only thing you have to be careful, which we've been doing all year long so far, is that when you subtract, change it to adding these opposites. So it's going to be negative 16 and a negative 3i. So then 12 and negative 16, 12 plus negative 16, since they're the real parts, is a negative 4. And then negative 2i plus negative 3i is just negative 5i. Okay? So just combine the real parts and combine the imaginary parts. Okay? Then the next one, well, let's just jump down here as well. Let's go ahead and let's do the addition as well. So again, the real parts are a positive 4 and a negative 6. Since it's already adding, we don't have to change anything, so that's a negative 2. And then the imaginary parts are a positive 4i and a positive 3i is a positive 7i. Okay, so that's as easy as we have it for these two. Alright, so then multiplying, in this case, we actually don't have to use our box because it's not a binomial. It's not a binomial times a binomial. Up in the example, we had 2 parts. They both had binomials. It was a real and an imaginary, and then another real and imaginary. This one, it's just an imaginary times each of those. Okay, so you can distribute it. Okay, which negative 4i times 9 is negative 36i. And then negative 4 times positive 5i, excuse me, negative 4i times positive 5i is negative 20i squared. Okay, and then again, that I squared, we really have to get used to recognizing that, because I squared, remember, is actually the number negative 1. And so this negative 1 changes that sign. So whenever you see an I squared, all it's ever going to do is change whatever the number is with the I squared to the opposite sign. So that's actually negative 36i plus 20. Okay, because that changes that minus to a plus. And a lot of times we write the real part first. So you could also see it as 20 minus 36i. Okay? Let me make sure that's an I. Okay? Now, I would take either one. I mean, it's really easy to, the commutative property says we could change their order. So it's really easy to see whichever one it is. But I know, like in things that I do see the real being first and the imaginary being second. Okay? All right, so for this last one over here, we are dividing, and we have to get rid of the I in the denominator. Remember, we don't want an I right here. So we have to use its conjugate. And its conjugate, remember, is almost identical to the denominator, but we have to do it the opposite. So since this is plus I, the conjugate is going to be a minus I. Okay? And whenever we do on bottom, we have to do on top. So now we actually have 2 binomials. Oops. Now we actually have 2 binomials that we have to go off to the side and multiply. We have to multiply these 2 for the numerator. So that's 8 minus 4i and 3 minus I. Okay? Let me make sure you can see that. Yeah. Okay. So we're going to multiply that in, and then we also need to multiply the denominator. So that is 3 plus I and 3 minus I. Okay. So we've got binomials multiplying. So this is an example of where we have to do a little bit more. Let me grab the purple. There we go. So we get 24, negative 12, negative 12i. Then we get negative 8i. And then negative 4i times negative 1i is a positive 4i squared. But again, that I squared jumps out at us. We have to recognize that is a negative 1. So instead of a positive 4, that negative 1 is going to change it to a negative 4. Okay? So the numerator, we just put the real numbers together. 24 minus 4 is a 20. And then I put the imaginary parts together. Negative 8 plus negative 12 is negative 20. So that's the numerator. And then the denominator, we just go through the same thing. We get 3 times 3 is 9. We get a positive 3i. We get a negative 3i, which is exactly what we want. Positive 3i and negative 3i cancel. Positive I and a negative I is a negative I squared. But I squared, remember, means negative 1. So instead of a minus a number, it's this negative 1 changes it to plus. And in this case, it's plus a 1. Because there's no number, so the number's automatically 1. So instead of minus something, it's now plus that 1. So those two cancel out. 9 plus 1 is 10. And the last thing we have to do is we do have to reduce it. So if you want to look at it separately, you can. Or if I like to look at it all together, because it's all one problem, all of these can divide by the number 10. So whenever you are looking at these fractions, and we've got to practice these because we're going to see them all unit long, okay, we always want to reduce. Okay, so since all three of those divide by 10, then I want to think to myself, let me divide each of these by that 10, and it reduces. It's just like fractions. If you've got a numerator and a denominator that you can divide something out, that's what we do. So 20 divided by 10, we'll reduce it down to, I'm going to do it one more time with this purple. There it is. All right, 20 divided by 10 will reduce down to a 2. Negative 20i divided by that 10 will reduce down to a negative 2i. And then 10 divided by 10 is just the number 1. And since it's over a 1, 1s are automatic, so you actually don't even have to write it. That's the whole point, is that I actually just divided each of those by that 10, and it reduced all the way down to just a basic 2 and 2. And we've got to keep practicing that because we're going to see that a bunch of times as we go, okay? All right, so that is subtracting, multiplying, or distributing, same thing. Dividing, getting that I out of the denominator, rationalizing it, and then adding at the end, which we'd already covered, okay?